Hello everyone, we are from Group 12. Our presentation will be focused on delay release, and the topic of our presentation is a developed composite hard gelatin capsule. These are our group members. Each of our group members were presenting their own part.
Firstly, we are going to look into the dosage form. The drug is inside a gelatin hard capsule with delayed release properties for oral administration. It can also be referred as enteric-coated medication.
Hello, I will present the formulation design part. To formulate hard gelatin capsule with enteric properties for acid resistance, a composite of gelatin and hydroxypropyl methicellulose platelet or non-HPMCP is used. Gelatin, source of racilloids, serve as the base material, while HPMCP act as enteric polymer to ensure the capsule remains intact in the acidic pH of the stomach, facilitating delayed release. The formulation includes distilled water as a solvent, ammonia to dissolve HPMCP, and polyvinyl alcohol, polyethylene glycol C100, and glucomannan for delayed release properties. Additives such as sodium lauryl sulfate, methylparaben, propylparaben, color, and acetic acid are incorporated during the encapsulation process. The drug release evaluation involved 4-hydroxyacetylene. This formulation leverages a combination of natural, semi-natural, and synthetic polymers to achieve the desired delay release characteristic.
Next, let's look into the formulation rationale. The main aim is to enable the gelatin hard capsules to be delivered in the small intestine and prevent degradation of the capsule by gastric acid in the stomach. Some drugs need to be released in the intestine to exert a local effect there, for instance, like drugs used to treat intestinal diseases. Some drugs will be degraded by gastric acid in the stomach. The effectiveness of the drug will be affected. Thus, enteric-coated medication are used to protect the drug in the acidic environment of the stomach. The addition of intestinal polymers enables only small amount of drugs to be released in the stomach, while the rest of the capsule's content will be completely released at the target site, which is the intestine, providing a delayed release system. pH regulates the drug's release, which happens gradually over time. This can give a localized effect in the small intestine.
Now let us proceed with the technology involved in the formulation. After mixing and preparing the ingredient for the capsule cell, which include gelatin as the base material, hydroxypropyl methicellulose bicarb as the compositing polymer, polyvinyl alcohol and glucomannan to achieve delay release and other necessary ingredients, the next step involved is capsule fabrication. Deep coating method is used to produce delay release hard gelatin capsule. The temperature of the prepared solution is kept at 38 degrees Celsius, which is slightly higher than the temperature of the metal pin, which is in the range of room temperature.
Then, the metal pins are dipped deliberately into the prepared composite solution at a constant rate using manual pin bars. To ease the capsule removal process after they are dried and hardened, the pins are coated with edible lubricants and food oil. Next, the capsules were dried at room temperature and the humidity was adjusted to 38% to 40% to prevent the capsules from becoming brittle under low humidity or deform under high humidity. The pins were also dried under blowing air to speed up the drying process. The dried caps and bodies were removed from the molding pins, trimmed to an appropriate length and pre-locked. An immediate visual inspection will be done and capsules are packed.
Now, we proceed to the formulation methods.
Step 1. Gelatin solution preparation. Gelatin is dissolved in purified water at controlled temperature, which is around 60 to 70 degrees Celsius, to form a concentrated solution with the desired viscosity. Step 2. Dip coat the gelatin solution onto molds. Stainless steel pins shaped like the capsule body and cap are dipped into the gelatin solution, forming a wet coating.
Step 3. Drying process. Coated pins are designed to run through a furnace for setting and drying purposes. To successfully remove moisture from the capsule, the temperature and humidity must be carefully controlled during the procedure. Step 4. Stripping and trimming process. The pin plate will now enter the machine stable section. Capsules are separated into two equal or about equal sizes. Later, these are removed from the pins. Shell trimming occurs once the stripping procedure is complete. The machine will automatically combine the two parts for you. These blocks are now transferred to the conveyor belt and later to the container. Step 5. Printing. The printing stage entails adding all important information such as dosing recommendations, promotion, and capsule identification. For Step 6. Testing. Testing occurs once the printing phase is completed. The capsule must go through a series of stringent quality testing to ensure that it is of the required quality and has a long shelf life. Our last step is step 7, packaging. The final stage of capsule production is packing. Capsules are now packaged in a normal manner. At this step, conventional packaging is employed to make the capsule easier to handle.
Next, we proceed to consideration. The first advantage is drug protection. Ensuring enteric coating shield acid-sensitive medication reach the intestine for effective absorption. Second is reduce stomach upset. Enteric coating minimize irritation of the stomach lining caused by certain medication. Third is targeted delivery. Control drug release in the small intestine that act best at specific efficient in the digestive system. Next, we move on to challenge. The first challenge is formulation complexity. Developing a stable and effective enteric coating requires careful selection of polymers, precise formulation design, and proper coating technique. Next, variability in GI transit. The time it takes for the capsule to reach the intestine and dissolve the enteric coating can vary depending on the factor like food intake and gastric emptying time.
Now, let us proceed with the performance and evaluation of the formulation, which is hard gelatin capsule. The hard gelatin capsule is produced by incorporating HPMCP, which is an acid-resistant polymer that allows the capsule to remain unchanged in acidic environment and only release its content when the capsule reaches small intestine. The capsule remains intact for about 20 to 30 minutes after entering the stomach. After that, it will slowly release and reach the small intestine in around 90 to 100 minutes. Once the capsule reaches the small intestine, the rate of release of the active ingredient increases rapidly.
Why the rate is different as in stomach?
This is because the capsule shell that is incorporated with the HPMCP is dissolved completely in the small intestine, and this allows the active ingredients to be released at a faster rate. Next, according to the result obtained from scanning electron microscopy, the surface of the capsule is smooth and there is no bulges or deformation exist. Secondly, there is no interaction has been observed between the combination of HPMCP and polyvinyl alcohol with gelatin as they are compatible with each other. So, we can conclude that the addition of HPMCP polymer to gelatin in the production of hard gelatin capsule does not change the physical appearance of the capsule and does not cause any undesirable interactions.
Moving forward is the viscosity test.
Viscosity test is carried out to investigate the viscosity of pure gelatin and develop delay-release composite polymer.
Since the gelatin-based solution has a very high viscosity, water can be added to adjust the viscosity, which is compatible with the deep coating device to form a lower viscosity of delay-release composite polymer solution. Besides that, relative humidity is the moisture in the capsule, which is the amount of the water used to solubilize and dilute the solution.
The hydrometer is used to calculate the moisture percentage in the capsule at a specific amount and temperature. According to the report, the developed delay-release capsule with polyvinyl alcohol has more humidity than the glucomannan capsule due to their immediate dehumidification after drying.
Now let's proceed to the importance of the formulation comparing with other conventional dosage form. Conventional hard gelatin capsule shell that only made out of gelatin is sensitive to the stomach acidic environment. For our formulation with delay-release enteric properties, gelatin is combined with enteric polymers to reduce its sensitivity to the acidic environment. Conventional hard gelatin capsule have low bioavailability and limited clinical efficacy due to no pH and time control release ability. The drug degrades and lost medicinal properties in stomach, causing it unable to exert local effect on intestine. For our formulation, have a higher bioavailability and higher clinical efficacy. The capsule remains completely intact when passing through the stomach, and the active ingredient release rate will only increase when reach intestine. Conventional hard gelatin capsule may need frequent dosing due to the release of drug is unstable, varying half-life of drug and fluctuating plasma concentrations may happen to patient. For our formulation, the improving of release stability behavior of capsules reduces the frequency of drug delivery while increases the stability of the dose release in a single dosage. Overall, conventional hard gelatin capsule have a poor drug performance because it is unable to bypass the gastric region and will cause irritation to stomach. Composite hard gelatin capsule with delay-release enteric properties will have a better drug performance due to its high drug release rate and more absorption will be achieved in intestine.
These are the references that used in our presentation. That's all from us. Thank you.